Okay, hello everybody. This is lesson 1 from chapter 1 on roots and powers. So I'm going to just zoom in here a little bit. There we go. Okay, and the key learning here today, we're going to be looking at square roots and cube roots and understanding how those work. So let's just start off with a little bit of a warm-up, just to get used to some of the notation again. Here we have some expressions. Some of them are exponents and some of them are radicals. So 6 squared, just remember that 2 means you're multiplying 6 twice. So it'd be 6 times 6, which is 36. Square root of 36 asks, what number do you multiply twice to make 36? There actually technically is a little 2 here. We just kind of have dropped that 2 over time because we write the square root so often. But there technically is a 2 there, and it means what number do you multiply 2 times to make 36? The answer is 6. 4 cubed, that means, so the 3 means multiply the 4 3 times. So 4 times 4 times 4 would be 64. And the opposite of that is a cube root. So the 3 here means what number do you multiply 3 times to make 64? So since 4 times 4 times 4 is 64, the answer to that would be 4. Okay, so that was our little warm-up to remind you about what exponents and what square roots and cube roots mean. We are going to skip, well, actually, no, we'll do this one. So let's look at these. We're going to take some square roots and some cube roots here. So let's look at the number 1. 1 is kind of a special number because you can take any kind of root of it and it's going to give you 1 back. Since 1 is just 1 times 1 times 1 times 1. The square root of 1 would be 1. The cube root of 1 would be also 1. Let's look at 4. It's a little more interesting. So 4 is equivalent to 2 times 2 if you break it down. So the square root of 4, that asks what times what equals 4. And so the answer to that would be 2. If you try to take the cube root of 4, though, you wouldn't get a whole number because there's nothing that you can multiply 3 times to make 4. So for that, you would either have to estimate it or you would have to use a calculator. We're going to use a calculator for that. I'm just going to do a new one, file new. There we go. Okay. Great, and we're going to just put the calculator in the corner here. Okay, so you have to get familiar with your own calculator and where your cube root button is located. For mine, it is located in my math button, but yours is probably on your screen somewhere. So I'm going to type math, and I just scroll down to get the cube root. You'll have to find yours. If you can't find it, let me know, and I can find it for you. So I'm going to do cube root of 4. And I get some long string of decimals. That's because this number is actually irrational. That long string of decimals actually goes on forever. And we'll get to that more in the rest of the chapter there, but it's going to be 1.587, and then it just keeps going forever. So I'll do 587, and then I'll put ... Okay. 8. So 8. If you break that down, 8 is actually 2 times 2 times 2. So you actually can take the cube root of 8. That asks, what do you multiply 3 times to make 8? Well, the answer is 2. But if I try to take the square root of 8, there's actually nothing I can multiply twice to make 8. So that I would need a calculator for. My square root button's right on the screen here. And that's going to give me a decimal. 2.828 goes on forever, so I'll just stop there. So I'll put 2.828 ... And we can keep going here. I'll do one more and then we'll stop. But so 9 is 3 times 3. So we can easily take the square root of 9, which is 3. But if we try to take the cube root of it, there's nothing that multiplies 3 times to make 9. So we would need our calculator for that. I'll just find my cube root and I'll click 9. So it'd be 2.08 ... Okay, so you get the idea. Some numbers are perfect squares and you can take their square root and it gives you a nice whole number. And some numbers are perfect cubes, and if you take their cube root, you get a nice whole number. So the number here, 8, that is we call that a perfect cube. Because if you take the cube root, it works out nice and evenly into a whole number. But these ones here, the 4 and the 9, these are perfect square numbers. Because if you take the square root, you get a nice whole number. And I'm sure you've heard of these terms before in your previous classes, or at least you should have. One is special because it's both. It's a perfect square and it's a perfect cube because both of those work out to be a whole number. Okay. We're going to skip those questions there. We're going to go over some key terms. So you need to know these terms. I'm going to be referring to them throughout the chapter. N here is the index. So the index tells you how many times you need to multiply to make the number. So on a typical square root, the index is 2. And like I said, we don't typically write the 2, but in all other radicals, we do write it. A is called the radicand. That's the number that's inside the root. Okay. The root, this is called the root symbol. And the entire thing is called a radical. So an example of a radical would be like something we were just doing there, cube root of 8. That's a radical, okay? All right, the 3 index would be 3, and the radicand would be 8, but the entire thing would be called a radical. Okay, we already mentioned perfect squares and perfect cubes. Okay, a perfect square is when the square root works out perfectly, so 36 would be a perfect square because the square root of 36 is exactly 6. And we mentioned a perfect cube already. That's when the cube root works out nicely to a whole number. Okay, and then the last little note I'll make here is something called the principal square root. Because technically, like if you're looking at the square root of 36, technically you could say it's 6 because 6 times 6 is 36. But you could also say it's -6 since -6 times -6 equals 36. But we always use the positive answer. So that's what's called the principal square root. So technically both of those answers are correct, but we always use the positive answer when we're answering our square roots. Okay. And we'll skip that, and we'll go to our first example here. So I'm going to do the check your understanding. If you want to read through the example that they go through, you can. But we're asked here to estimate the value of the radical to 1 decimal place. So these aren't going to work out perfectly. They're not perfect squares or perfect cubes. And so we're going to need to estimate. And we're going to do so without using the square root button on our calculator. Without any radical button. Okay, so we need to think of what's called benchmarks. So square root of 65, that's not going to work out. Nothing can multiply twice to equal 65. However, I can think of something that's maybe close to 65 that does work out nicely. So benchmark is something that you use to help you estimate. So I know that root 64 equals 8, since 8 times 8 is 64, and that's pretty close to root 65. So maybe my answer is going to be close to 8. And I also know the next highest one would be, I guess, 81, since 9 times 9 is 81. So my answer to square root of 65 is going to be between 8 and 9. And I would guess it's a lot closer to 8 than it is to 9, since 65 is a lot closer to 64. So I'm going to guess 8.1, since I know it's just going to be a little bit higher than 8. And I'm going to check in my calculator. 8.1. I'm not allowed to use the square root button when I'm guessing here. So the way that I check is I just multiply it twice and see how close to 65 I am. So I'm going to square this number and see how close to 65 I get. I have to start a new one. I don't know why it makes me start a new one every time, but that's okay. Oops. Okay, so let's move this over here. Oh, it's not letting me. Okay. So I'm going to, well, I guess I have to move this maybe. I'll move this over here for my calculator. There we go. 8.1 squared equals. So 65.61, it's 65.61. That's pretty close. It's a little high. So I'm also going to check 8.0 just to see if that's a better estimate. 8.0. Oh, we already know that's 64. 64. That's further away. So this is better. So then we can say final estimate. Square root of 65 is approximately, we use a little squiggly equal signs to mean like approximate or estimate, 8.1. So then I would highlight that and say that's my final answer, but everything above that is kind of my work. So we think of our benchmarks, we make a guess, we check with our calculator, and then we come to our final estimate. If you want to pause here and try the cube root of 80 on your own, you can do so, or if you want to do it with me, you can keep watching. So we'll do the cube root of 80 as well. So for part B, I'm going to come up with my benchmarks, and I have to think of some nice perfect cubes that will work out nicely. So I, for example, know, and you could play around with your calculator and check these out, but the cube root of 64 actually works out perfectly. It's 4. And then 5 times 5 times 5, that's 125. So the next highest one is 5. The perfect cubes are kind of few and far between. So 81 is kind of, 80 is kind of in the middle there. It's a little bit closer to 64 than it is to 125. So I'm going to guess maybe 4.3. You could guess 4.4, something in there. So let's check. I'm going to see how, if I cube 4.3, how close is that? So 4.3 cubed is 79.507. That's actually really close. It's a little too small. We're trying to get 80. So I can try 4.4, but I'm pretty sure 4.3 is going to be the answer. 4.43, 85. Yeah, that's too big. What was the decimal? 85.184. That's best. So then my final answer cube root of 80 is approximately, so we use the little squiggles. You have to use the right symbols when you're writing down your math, so pay attention to those little details. You do need to use the squiggles to get full credit on a question like this if I was asking you to show all your steps. 4.3, because it's not exactly equal, and we don't want to say that it's equal. Okay, if I actually did the cube root of 80, right, it's not exactly 4.3. So we don't want to say it's equal to 4.3. We want to say it's approximately 4.3. Okay, so there we go. That's how you estimate, and you don't want to use the cube root or square root button when you're estimating. You want to do it without that. If you need to see another couple of examples, they're written here for you. So that's how we'll do these videos, is I'll do the check your understanding questions, and then if you need more examples, you can look at the ones that are already written down. Okay, so we're going to skip ahead here and go to these next questions. We're now going to work on finding the square root of fractions. Sometimes these fractions will have to be modified before we can take the square root of them too. So we have to remember some fraction skills. So let's just go right into the example here. So A, 162, and these are actually going to come out with an exact answer, 162 over 50. Now, if you're working with a fraction, we can recall that fractions can be reduced. And so right now, as it is, I can't think of numbers that multiply to make 50 or 162, but I can reduce this fraction because both the numerator and the denominator are even. So I can divide those by 2, and we get 81 over 25. And the way that square roots of fractions work is you actually just take the square root of the top number and the square root of the bottom or denominator, and that's your answer. So this is the same as taking the square root of 81 over the square root of 25. And so we have to think of two numbers that multiply to make 81. So 9 times 9 is 81, so that would be 9. And square root of 25 would be 5. So you should be able to do that without using a calculator. Just get that on your own. Okay, so then for part B, this one cannot be reduced over 343. Neither of those numbers can be divided by anything, but 27, we can answer these directly. The cube root of 27 is 3, since 3 times 3 times 3 is 27. So this would be 3. And the cube root of 343, if you actually multiply 7 times 7 times 7, it's 343. You can double check here. 7 times 7 times 7, 343, yeah. So we can just make 3 over 7. There we go. And that's actually the end of the lesson. So just a little review of radicals and cube roots and square roots.